Today we're going to look at perfect squares in quadratic expressions. Perfect squares in quadratic expressions. All right. Now, it's important to note that when perfect squares are factorized, the factor becomes x plus a into x plus a. A recap: when perfect squares are factorized, when quadratic expressions, which is a perfect square, is factorized, the factor becomes x plus a into x plus a. And if you check this means x plus a all squared. So the factor repeats itself. The factor is squared. Yes, it's important to note that. Take for instance, for example, if I factorize the expression, x squared minus 10x plus 25. If you are factorizing this expression, you will see that, of course, the first thing you need to go about doing is multiply the first term and the last term. Multiplying the first term and the last term, you are going to have 25x squared. So the next thing you're going to do is that you will find factors of 25x squared. Find factors of 25x squared such that when you add, it's going to give you the middle term, which is minus 10x. So the factors of minus 25x squared are minus 5x and minus 5x. Yes. Such that when you add these factors, it will give you minus 10x. Let's add it and see. So minus 5x plus into minus 5x, of course you see is the same thing as minus 5x minus 5x. That obviously gives you minus 10x. That means that these factors are correct. If you choose factors of the product of the first term and the last term, and those factors of that product does not give you the sum of the middle term, we cannot go with that factor. But for the fact that the sum of those factors gives you the middle term, means that those factors are correct. So this quadratic equation this quadratic expression will become x squared minus 10. I'm going to replace minus 10 with minus 5x minus 5x, because when I add them, plus that's minus because minus, so this is plus 20, 25. All right. So from there we factorize. So 3 terms has become 4 terms. So I'm going to group these 4 terms in 2 groups. The first group and the second group. All right. Factorizing the first group of 2 terms, the highest common factor between x squared and minus 5x is x. All right. To get what is inside the bracket, x squared divided by x gives you x. Minus 5x divided by x gives you minus 5. We bring down the minus sign, but what we have inside the bracket here is 5x and 25. So the highest common factor, of course, is 5. Open the bracket. What we have here is x plus 25 divided by minus 5 is going to give us minus 5. Moving forward, we can see that the term inside the bracket seems to repeat itself. So what happens? All right, because they are repeating themselves. All right, they will become the highest common factor. This is one term, and this is another term. Take note: 4 terms are being factorized, and we are having something like this. Then, because these factors repeat itself, we are going to simply have x minus 5, close the bracket, and then we are going to pick the terms outside the bracket. The terms outside the bracket is also x minus 5. All right. If you look at this, it's the same thing as saying x minus 5 all square. X minus 5 all square. So comparing this, all right, you will agree with me that this is of the same form as x plus a all square. Remember I said that the factor of a quadratic expression that is a perfect square is of this form. So if I'm comparing this, you can see that the value of a here, by comparison, the value of a is minus 5. The value of a is minus 5. X plus a, all right, x plus minus 5, because plus minus is minus. So that is fixed. Now, it is important you know that because this is a perfect square, in the equation which we have just looked at, if for x squared minus 10x plus 25, all right, factorizing this expression gives us what we've had already, gives us x plus a all square, which is we know x minus 5 all square. It is important that you know this, because this is very instrumental for the facts we are going to establish as we proceed, as we move forward from here. I hope you know that if I am to expand this, this will be x plus a into x plus a. Expanding this, of course, we know how we'll do this. X times x is x squared. X times a, x times x is x squared. X times a is ax plus ax. I'm done with x. Now a times x is plus ax. I'm done with that, and the next is a times a is a squared. All right. So you can see that if I expand that, ax plus s is 2ax. What I'm going to have finally is x squared plus 2ax plus a squared. All right. It is instrumental as we move forward from here. So we can see we have established the fact that this is a perfect square because the roots, the factors rather, repeats itself, and it's in the form x plus a all square, which will give us x squared plus 2x plus a squared. Let's look at an example. All right. What must be added to x squared minus 10x to make it a perfect square? From what we've established from the beginning of this class, you will agree with me that the answer is going to be 25. You agree with me that the answer is going to be 25. All right. In as much as we know that that's the answer, the purpose of this class is that we're going to work it out and see how we'll reach 25 as the answer. Let's begin. So if you look at this, there are two methods you can do this. All right. The first method, which I will be using with you, is method of completing the square. That's the first method. And in that method, all right, the first step we're going to take in that method is that we will make sure that the coefficient of x is unity, x squared rather. The coefficient of x squared is unity. What I mean is the coefficient of x squared must be 1. How do we make that to happen? We make that to happen by dividing all through, dividing each term all through by the coefficient of x squared. But you can see that the coefficient of x here is already 1. So it makes almost no difference dividing all the terms by the coefficient of x squared. So we can continue solving it like that. So the first step is already accomplished, that this is x squared minus 10x, all right, plus k. Now k is what we will add to make it a perfect square. So if I divide all through by 1, divide all through by 1, divide all through by 1, it's still going to give me that expression. Now the second step, step 2, all right, is that okay, let me just divide by 1. Divide by 1 is still the same thing, x squared minus 10x plus k. All right, so the second step is I will have the coefficient of x. I will have the coefficient of x. The coefficient of x is minus 10. I will have it. Having the coefficient of x is something as multiplying the coefficient of x by 1 over 2. When I multiply the coefficient of x by 1 over 2, I will square the result. Alright, so the coefficient of x is minus 10. I'll multiply it by half. Alright, this gives me minus 10 all over 2. And then after that, I'll do what? I will square the result. I'm going to square the result. Now, doing this will give you minus 10 squared gives you 100 divided by 2 squared will give you 4. So the answer here would give you 25. Now, in step 2, whatever we are doing, we are equating what we had here to step 2. So it's like saying that k in step 2 from step 1 is equals to that. Alright, so the next thing we are going to do here is putting the value of k into this expression, and of course you can see that it's 25. Or you can still go this way. 10 divided by minus 10 over 2 would give me minus 5 all square. Minus 5 all square. Alright. You can still say that k is equals to minus 5 all square. Alright. Minus 5 all square is still the same thing as 25. It's still the same thing as 25. So anyhow you want to go about that, alright, so the perfect square expression becomes x squared minus 10x plus k, which is equal to x squared minus 10x plus, remember the value of k is minus 5 all square. Now to factorize the perfect square, it's simple. Alright. I'm going to pick x. I'm going to pick what's inside that bracket, and that will be x. What's inside the bracket is minus 5, and because they were both squared, that is what I'm going to have. So that's x minus 5 all squared. You can agree with me that this is exactly what we had. So we're going to move to the second method quickly, and the second method would be by comparing coefficients. The method of comparing coefficients. Now, in the method of comparing coefficients, we will establish this fact that x squared minus 10x plus k, we are looking for this, is the same thing as x squared plus 2ax plus a squared. So we're going to compare coefficients. The first term is x squared, the first term here is x squared. Of course, you see that cancels out. What we have left is that we are comparing minus 10x equals to 2ax. We can call that equation 1. Minus 10 and 2a. X is common on both sides, cancels out. So we have left is minus 10 is equal to 2a. So to find a, I'll divide both sides by 2. So minus 5 is equals to a. Or you can say that a is equals to minus 5. So from here, remember that a is minus 5. Comparing coefficients, the value of k is equals to a squared. We call that equation 2. So if the value of a is minus 5, that means k is going to be minus 5 all squared. And of course, minus 5 all squared is something as minus 5 times minus 5, which gives you 25. Which gives you 25. All right. So you can see there that completing the square and using the method of comparing coefficients, we have arrived at the same answer. We'll move to example 2. So example 2, what will be added to 2x squared plus 5x to make it a perfect square? All right. Solution. What is that term? What would be the constant k so that this expression would be a perfect square? All right. So the constant denoted by k. Now the first step is that the coefficient of x squared must be unity, must be 1. But fortunately, the coefficient of x squared is 2. So what I'm going to do is that the first step, I will divide all through by the coefficient. So divide by 2, and then I will divide by 2. And then when I do that, this will become x squared plus 5x all over 2 plus k over 2. From here, the second step is we are going to multiply the coefficient of x by half and square the result. So the coefficient of x is 5 all over 2. We'll multiply it by half and then we'll square the result. This becomes 5 all over 4 all square. 5 all over 4 all square. All right. Now, if you look at this closely, you will discover that what we are doing in step 2, is that we are finding the value of k over 2. Yes, that's what we're doing in step 2. So we are saying that k all over 2 equals to this. Yeah, so k all over 2 equals to, of course, that will become 25 all over 16. So to find k, this is 16k equals to 2 times 5 is 50. So to find k, I divide both sides by 16 so that k is equals to 50 all over 16. But that is not so simplified. 2 can go, this is 8 times, and 2 can go, this is 25 times. So the value of k is 25 all over 8. The value of k is 25 over 8. Alright. So what we need to add to make it a perfect square is 25 over 8. Remember the question? Note this. The question was 2x squared plus 5x. What are we going to add to make it a perfect square? What are we going to add? So that thing, we called it k. We called it k. And then we've just found k as 25 all over 8. So the value of k is 25 all over 8. So 25 all over 8. 25 all over 8. So we've been able to tackle this by completing the square, method of completing the square. So the second method, which is the method of comparing coefficients, which we're going to do, 2x squared plus 5x plus k is going to give you that, x plus a all squared. Alright, so this becomes 2x squared plus 5x plus k equals to, if you expand that, it's going to give you x squared plus 2ax plus a squared. Alright. Moving forward from there, you can see that the coefficient of x squared is not unity, is not 1. So I'm going to make it 1. How am I going to do that? I'll divide all through by 2, all through by 2, all through by 2. So that cancels. Alright, so this becomes x squared plus 5x all over 2 plus k over 2 equals to x squared plus 2ax plus a squared. So by comparing coefficients, you can see that x squared will cancel x squared. So let's compare 5x all over 2 to ax. 5x over 2 equals to plus 2ax. Of course, this is equation 1. X cancels x. Alright. And what we have left is 5 all over 2 equals to 2a. By cross multiply, I want to find a. I'm going to have 5 equals to 4a. Alright, so a is obviously 5 over 4. Therefore, okay, let me put it this way. A is equals to 5 all over 4. The next thing we're going to do is we will compare k over 2 to a square. Okay, so moving forward, a equals 5 over 4, k over 2 is equals a squared. That's equation 2. Another comparison. So remember that k over 2, I'm substituting a in there. So this is 5 all over 4. 5 all over 4 all square. 5 all over 4 all square. Alright. So you can see here that this will become k all over 2 equals to 25 all over 16. So I want to find k. So cross multiply 16k equals to 2 times 25. That means that 16k equals to 50. Alright, to find k, I'll divide both sides by 16. So k gives me 50 over 16. 2 goes here, 8, 2 goes here, 25. So that still gives me 25 all over 8. The same answer. The same answer. Alright. So that means that using comparing coefficients method or the method of completing the square, you are still going to have k as 25 all over 8. So food for thought, from what we've just found, remember that the value of a is 5 over 4. X plus a all square would give us the quadratic expression. So we can say that x plus 5 over 4 whole square will give us 2x squared plus 5x plus 25 all over 8. You can check this for yourself, expand this, it should give you this. Check it out. I have a question for practice, and that's obviously presented before you here. What's the value of k so that 3x squared plus 2x plus k is a perfect square? So that 3x squared plus 2x plus k is a perfect square, should be a perfect square. Alright, so solve this question, put your answer on the comment section. I will react to it. Don't forget, happy independence to Nigeria. This video was made on Nigerians independence. Happy independence to you, happy independence to me, happy independence to us, happy independence to Nigeria. See you in my next video.